NASA Dream Chaser, a journey through history, present, and future. Introduction. The Dream Chaser spacecraft, developed by Sierra Space, represents a significant leap in the evolution of reusable space vehicles. The design is rooted in the HL-20 personnel launch system created by NASA, showcasing a blend of historical innovation and contemporary engineering. This report details the Dream Chaser's historical development, its current status, and future aspirations, outlining its role in NASA's commercial space initiatives and its potential to reshape space transportation. Historical development. Origins in the 1980s. The Dream Chaser's lineage can be traced back to the 1980s with the HL-20 concept, inspired by the Soviet BR-4 spacecraft. Developed at NASA's Langley Research Center, the HL-20 was designed to serve as a crew transport vehicle with horizontal landing capabilities. Initial tests conducted in the early 1980s demonstrated its favorable aerodynamic properties, but funding issues sidelined the project. Resurgence in the early 2000s. In 2004, SpaceDev, a company focused on commercial spaceflight, revived interest in the HL-20 design, rebranding it as Dream Chaser. The project gained momentum after SpaceDev was acquired by Sierra Nevada Corporation SNC in 2008. The Dream Chaser was selected by NASA in 2010 as part of the Commercial Crew Development CCDEV program, receiving significant funding to further its development. Key milestones. 2010, NASA awarded $20 million to Dream Chaser for initial development. 2011, additional funding of $80 million was allocated to support the project. 2012, the Dream Chaser Engineering Test Article ETA completed multiple aerodynamic tests. 2014, although initially successful, Dream Chaser was not selected for the Commercial Crew Transportation Capability CCTCAP program, leading to a shift in focus towards cargo missions. 2016, Dream Chaser secured a contract under NASA's Commercial Resupply Services 2CRS-2 program, committing to at least 6 cargo missions to the International Space Station ISS. Transition to Sierra Space. In 2021, SNC restructured, forming Sierra Space as an independent entity responsible for the Dream Chaser project. This transition allowed for a more focused approach to developing the spacecraft and its associated technologies. Current status. Dream Chaser design and capabilities. The Dream Chaser is a reusable lifting body spacecraft designed for cargo transport to the ISS. Its design allows for up to 15 reuses, offering a cost-effective solution for resupply missions. The spacecraft consists of 2 main components, the Dream Chaser spaceplane and the Shooting Star cargo module. The latter is designed to support both pressurized and unpressurized cargo. Upcoming flight tests. Sierra Space is preparing for the first flight of the Dream Chaser in 2024, with a demonstration mission scheduled to launch aboard a United Launch Alliance ULA Vulcan Centaur rocket. The spacecraft will be tested for its in-orbit capabilities, including autonomous rendezvous with the ISS and operational integration with NASA's mission control. Future missions. Once operational, the Dream Chaser is expected to deliver over 7,800 pounds, approximately 3,500 kilograms of cargo to the ISS and return significant amounts of scientific samples and experiments back to Earth. Future iterations may include a crewed variant capable of transporting astronauts, expanding the spacecraft's utility in both commercial and governmental missions. Future aspirations. The Dream Chaser project is not only a testament to the evolution of space transportation, but also a crucial player in the emerging low Earth orbit economy. Sierra Space envisions the Dream Chaser as a central hub for various commercial operations, including potential partnerships with international space agencies and private enterprises. Potential applications: international resupply missions. The Dream Chaser's design allows for versatile missions beyond just resupply, including potential operations in lunar orbit and other destinations. Commercial space stations. In collaboration with Blue Origin, Sierra Space aims to establish commercial space stations, with the Dream Chaser providing essential transportation services. Global utilization. The spacecraft is also being considered for missions that could support the United Nations goals of expanding access to space for developing nations. Technological innovations. The Dream Chaser incorporates advanced technologies, including a unique thermal protection system and propulsion capabilities. The Shooting Star module enhances the spacecraft's versatility, enabling it to dispose of unwanted cargo upon re-entry, thereby increasing efficiency. Conclusion: the Dream Chaser spacecraft epitomizes the collaborative spirit of modern space exploration, blending historical insights with cutting-edge technology. As it prepares for its inaugural flight in 2024, the Dream Chaser not only promises to enhance NASA's capabilities in low Earth orbit but also aims to play a pivotal role in the global commercial space landscape. With its potential for resupply missions, crew transport, and international collaboration, the Dream Chaser stands ready to redefine our access to space for decades to come. Counterintuitive information in the development of NASA's Dream Chaser spacecraft. 1. Origin of the design. While many might assume that the Dream Chaser is a modern innovation, its design is rooted in the NASA HL-20 concept from the 1980s, which was inspired by earlier Soviet spacecraft. This historical lineage contradicts the perception that contemporary space technology is entirely new. 2. Funding and support. The Dream Chaser's journey reflects the unpredictable nature of funding in space exploration. Despite being selected for NASA's Commercial Crew Development (CCDEV) program and receiving significant investments, Dream Chaser was ultimately not chosen for the Commercial Crew Transportation Capability (CCTCAP) phase. This outcome underscores the notion that substantial financial backing does not guarantee a project's success or continuation, challenging the common belief that funding equates to project viability. 3. Reusable spacecraft limitations. The Dream Chaser is designed for up to 15 uses, which is a remarkable feature for space vehicles. However, the fact that it also includes an expandable module, the Shooting Star, complicates the narrative around reusability in space technology. This duality may appear counterintuitive, as the expectation for modern spacecraft is often to be entirely reusable, yet the Dream Chaser's design acknowledges the practical limitations and operational needs of space missions. 4. Delayed launch timeline. The Dream Chaser was initially slated for its first orbital flight as early as 2016. However, numerous delays have pushed this date out to at least 2025, which contradicts the assumption that spacecraft development timelines are typically linear and predictable. This highlights the complexity of aerospace engineering and the numerous unforeseen factors that can impact project timelines. 5. Hybrid propulsion evolution. Dream Chaser's propulsion system underwent significant changes, moving from a proposed hybrid rocket engine to a more complex pressure-fed engine system. This pivot challenges the assumption that hybrid systems are the pinnacle of modern engine technology, suggesting that sometimes the most straightforward solutions can be more effective in practice. 6. Landing techniques. Contrary to the expectation that advanced spacecraft would require complex landing systems, Dream Chaser employs a relatively simple runway landing approach, similar to the Space Shuttle. This choice underscores the practicality over complexity in spacecraft design, suggesting that sometimes traditional methods can be both effective and efficient. 7. Commercial viability. The Dream Chaser is part of a broader trend towards commercial spaceflight, yet its development has faced numerous hurdles that question the sustainability of such initiatives. Despite being designed for commercial use, the complexity and cost of development reveal the challenges inherent in transitioning from government-funded projects to commercially viable enterprises. 8. International collaboration. The Dream Chaser project has involved international partnerships, including potential collaborations with the European Space Agency (ESA). This international dimension may contradict the expectation that space missions are primarily national endeavors, highlighting the increasing globalization of space exploration. 9. Shift in focus to cargo. Originally intended as a crewed spacecraft, Dream Chaser's focus has shifted predominantly towards cargo missions. This change in direction challenges the narrative that crewed missions are the ultimate goal of space technology, suggesting that cargo missions may play an equally crucial role in future space exploration. 10. Public perception versus reality. The Dream Chaser project has often been portrayed in the media as a cutting-edge solution for space transport. However, its long development history and the cyclical nature of its funding and operational challenges present a more nuanced reality that contrasts with the simplified narratives often found in public discourse about space technology. These counterintuitive aspects of the Dream Chaser project reveal the complexities and challenges underlying modern space exploration, challenging assumptions about innovation, funding, and the nature of progress in aerospace technology. The NASA Dream Chaser project, developed by Sierra Space, is a fascinating journey through the history of American space exploration and commercialization. While many reports highlight its historical significance and upcoming missions, certain critical aspects are often overlooked. Here, I will identify these overlooked details and explain their significance. 1. The historical context of the HL-20 design. Many accounts mention that the Dream Chaser is derived from NASA's HL-20 personnel launch system. However, the deeper historical context surrounding the HL-20 and its predecessors, like the Soviet BR-4, is frequently glossed over. The HL-20's design process began during the Cold War, where technological competition was fierce. The original HL-20 was intended as a space taxi, and its design was influenced by earlier research into lifting body vehicles. Significance. Understanding the HL-20's origins provides insight into the evolution of space technologies and the geopolitical motivations behind them. It highlights how historical designs influence modern spacecraft, emphasizing continuity in aerospace engineering. The Dream Chaser represents not just technological progress, but also a legacy of international competition and collaboration. 2. The role of NASA engineers in Dream Chaser's development. The narrative often centers on Sierra Space and its commercial achievements, but the contributions of NASA engineers, particularly those who work on the HL-20, are less emphasized. Many of these engineers have remained involved, providing invaluable expertise and historical knowledge that has shaped the Dream Chaser's development. Significance. This collaboration exemplifies the synergy between public and private sectors in space exploration. It underlines the importance of institutional knowledge in technological advancements, showcasing how legacy systems and experienced personnel can enhance new projects. The blending of private innovation with public expertise could serve as a model for future endeavors in space exploration. 3. Commercial Resupply Services CRS-2 contract and its implications. The awarding of the CRS-2 contract to Dream Chaser is often mentioned as a milestone. However, the implications of this contract for the future of commercial spaceflight are often understated. By providing a reliable cargo resupply mechanism for the International Space Station ISS, Dream Chaser paves the way for a more sustainable low Earth orbit LEO economy. Significance: this contract indicates a shift towards reliance on commercial entities for space logistics, which can foster innovation and reduce costs. It suggests a future where private companies play a central role in human space exploration, leading to more frequent missions and diversification of space activities. The success of Dream Chaser could catalyze further investments in commercial space operations. 4. The Shooting Star Cargo Module. While the Dream Chaser itself receives significant attention, the details surrounding its Shooting Star Cargo Module are often overlooked. This module allows Dream Chaser to transport both pressurized and unpressurized cargo, significantly increasing its operational capabilities. It's designed for disposal of unwanted cargo upon reentry, which is a critical aspect of maintaining a clean and sustainable orbital environment. Significance: the Shooting Star module represents a crucial innovation in cargo transport. It not only enhances the payload capacity, but also addresses the growing concern of space debris. This foresight into orbital sustainability is vital for the longevity of space exploration and commercial activities in LEO, aligning with global efforts to mitigate space junk. 5. Landing techniques and environmental considerations. Dream Chaser's ability to land horizontally on conventional runways, similar to the Space Shuttle, is a remarkable feature that often doesn't receive adequate attention. The landing process involves strict weather criteria, and the craft's glide and control systems must perform flawlessly. Significance: this capability allows for the retrieval of experiments and samples, making Dream Chaser versatile for various missions. Furthermore, emphasizing horizontal landing speaks to environmental concerns. It minimizes the need for specialized landing infrastructure, potentially reducing carbon footprints associated with space operations. This approach could influence how future spacecraft are designed and operated, focusing on versatility and environmental impact. 6. Global collaboration and the Dream Chaser Global Project. The Dream Chaser is being positioned not only for U.S. missions but also as a global asset. The Dream Chaser Global Project aims to provide international partners with access to LEO. This aspect is often overshadowed by the focus on domestic achievements. Significance: this global perspective is crucial for fostering international collaboration in space exploration. It could lead to new partnerships, shared technologies, and joint missions that expand humanity's presence in space. By promoting global participation, Dream Chaser could help establish norms and standards for future space governance. Key potential for crewed missions. While the initial focus is on cargo missions, the planned crewed version of Dream Chaser is sometimes relegated to the background. The vehicle's design allows for a human-rated version capable of transporting astronauts to the ISS or beyond. Significance: the potential for crewed missions indicates that Dream Chaser could play a significant role in future human exploration initiatives, including missions to the Moon and Mars. This versatility underscores the importance of designing spacecraft that can adapt to various mission profiles, thus enhancing the investment's return and operational flexibility. Conclusion: the Dream Chaser project is a testament to the evolution of space exploration, showcasing a blend of historical legacy, technological innovation, and commercial viability. By paying attention to the overlooked aspects of its development and operational implications, one can appreciate the broader significance of this spacecraft in shaping the future of space travel and international collaboration. Understanding these nuances not only enriches our knowledge of the Dream Chaser, but also highlights the ongoing narrative of humanity's quest to explore the cosmos. 4 valuable points for in-depth analysis and discussion on NASA's Dream Chaser. Historical context and evolution. The Dream Chaser's lineage can be traced back to NASA's HL-20 personnel launch system, which itself was inspired by earlier designs and concepts in the 1980s. Understanding the historical context of the HL-20 and its evolution into the Dream Chaser underscores the importance of legacy technology and governmental private sector collaborations in aerospace development. The Dream Chaser project exemplifies how past research and designs can be revitalized and adapted for contemporary needs, particularly in response to the changing landscape of space exploration and commercial spaceflight. 2. Commercial spaceflight and NASA's partnerships. The Dream Chaser project illustrates the significant shift towards commercial partnerships in space exploration. NASA's collaboration with Sierra Space, formerly Sierra Nevada Corporation, through the Commercial Resupply Services (CRS) initiative highlights a new era of public-private partnerships. This transition aims to reduce costs, stimulate innovation, and enhance operational flexibility in low Earth orbit activities. Analyzing the implications of such partnerships can provide insights into the future of space exploration, particularly regarding how commercial entities can complement NASA's objectives. Technical features and innovations. The technical design of the Dream Chaser, including its reusable nature, lifting body configuration, and the incorporation of the shooting star cargo module, represents significant advancements in spacecraft technology. The Dream Chaser is designed for multiple missions with a reusability rate of up to 15 flights, which poses advantages over traditional expendable vehicles. Discussing these innovations allows for exploration into how advancements in materials, propulsion systems, and operational protocols can affect the long-term sustainability of space missions. 4. Future prospects and challenges. As the Dream Chaser prepares for its first flight in 2024, it faces various challenges, including technical readiness, regulatory hurdles, and competitive pressures from other commercial space vehicles. The potential future missions of Dream Chaser, including crewed flights and its role in the planned Orbital Reef Commercial Space Station, open discussions on the broader implications for human space exploration and the establishment of a low Earth orbit economy. Understanding these prospects and challenges is crucial for stakeholders aiming to navigate the evolving landscape of spaceflight in the coming decades. These points collectively highlight the historical, technical, and futuristic dimensions of the Dream Chaser program, offering a comprehensive framework for discussion about its role in the context of NASA's goals and the commercial space industry. 1. NASA Space Shuttle Program 1981 to 2011. The Space Shuttle Program was a revolutionary space transportation system developed by NASA, allowing reusable spacecraft to conduct missions including satellite deployment, space station construction, and scientific research. The program consisted of 5 operational orbiters: Columbia, Challenger, Discovery, Atlantis, and Endeavour, and completed 135 missions over its 30-year lifespan. The Space Shuttle served as a critical vehicle for human spaceflight and established a legacy of reusable spacecraft, influencing future designs like the Dream Chaser. 2. Boeing X-37 2006-present. The Boeing X-37 is a reusable robotic spaceplane developed for the United States Air Force. Initially conceived as a space research vehicle, the X-37 has evolved into a platform for various missions, including testing technologies for long-duration space missions. its design and operational capabilities, such as automated landing and reusability, have parallels with the Dream Chaser, highlighting the growing trend towards versatile, reusable spacecraft in both military and commercial contexts. Free Soviet BR-4 program 1980s. The BR-4 was an unmanned test vehicle developed by the Soviet Union as part of their spaceplane program. It was used to test various technologies related to thermal protection and reentry dynamics for future crewed spacecraft. The BR-4's design and flight characteristics influenced the development of NASA's HL-20, which later served as the basis for the Dream Chaser. The BR-4's legacy exemplifies how international efforts in spaceplane technology have shaped modern reusable spacecraft designs. 未来展望，梦猎者飞船的前景。梦猎者飞船 Dream Chaser 作为航空航天界的颠覆性技术，将在未来几年内迎来重要的发展。随着2024年计划中的首次飞行测试和以后的国际空间站 ISS 补给任务的接近，梦猎者不仅在技术上有着巨大的潜力，其商业应用和多样化的任务也将拓宽其市场。1. 首次飞行测试及后续任务。梦猎者的首次无人飞行任务定于2024年进行，主要目的是进行轨道演示和验证。成功的测试将为后续的载人飞行任务奠定基础。预计在2025年，梦猎者将开始为国际空间站执行实际的补给任务，完成多达6次的补给任务。每次任务将能够运送大量货物，包括超过3500磅的科学实验样品，并能处理超过8700磅的垃圾。这种能力将使梦猎者成为 ISS 补给的核心角色，进一步增强其在低地球轨道经济中的重要性。2. 可重复使用性与经济效益。梦猎者的设计使其具备高达15次的可重复使用能力，这在当前的航天器中是相对少见的。这种经济性不仅降低了每次发射的成本，还使得开发更多的补给和载人任务成为可能。随着航天发射市场的日益繁荣，梦猎者将能够吸引商业客户进行商业补给任务，甚至可能在未来的月球和火星探测任务中发挥作用。3. 载人版本的开发。虽然梦猎者初期版本为货物运输，但其未来的载人版本也在规划之中。根据最新的计划 ，Sierra Space 预计将在2025年前推出载人版本，这一版本将能够运送3至7名宇航员。载人梦猎者的成功开发将为 NASA 和其他国家的载人航天任务提供更多选择，提升全球航天运输能力。4. 国际合作与全球市场。梦猎者的成功不仅限于美国市场。随着 Sierra Space 与欧洲航天局的合作，以及与联合国的计划，梦猎者有潜力成为国际航天任务的重要运输工具。梦猎者的多功能性使其能够参与不同的任务，如科学实验、商业货物运输和国际合作项目，预计会吸引全球的合作伙伴与客户。5. 太空站与未来的商业机会。Sierra Space 与 Blue Origin 等公司的合作，计划共同开发轨道礁 Orbital Reef 商业空间站，梦猎者将在这一项目中扮演关键角色。作为承载人员和货物的交通工具，其在未来的商业空间站中将具备不可替代的作用。随着私人太空旅行和商业宇航活动的增长，梦猎者有望成为连接地球与太空的重要桥梁。6. 技术创新与发展。梦猎者的推进系统、热保护系统和自主飞行能力等关键技术的持续创新，将确保其在未来航天任务中的竞争力。预计这些技术将不断更新，为航天器的安全性和效率提供保障。此外，随着航天技术的进步，梦猎者可能会引入更加先进的材料和系统，使其在未来任务中表现得更为优秀。7. 结论。梦猎者飞船的发展历程体现了商业航天的快速进步与创新。通过不断的技术迭代和成功的任务实施，梦猎者将在国际航天市场中 占据重要地位。随着未来任务的展开，梦猎者有望不仅为 NASA 和国际空间站提供服务，还能在更广泛的商业和科学探索领域中大放异彩。这一项目不仅是对人类航天能力的提升，更是对未来太空经济的积极推动。